This is where we left each other. We were talking about things like Suzuki and Hex and making products and figuring out the difference between the two. I mean, who else can you have that type of conversation with except for me, right? So, in this video and in this example, we're given a task, and that task is to make these products A and B using Suzuki and Heck. And I first want to focus on Heck. And the reason is because, heck, we just did it. Okay? So, we're going to focus on part A, and we're going to talk about how to use Heck in order to make that particular product with. All right, so if I go back to the screen, it looks like this is a benzene ring with 1, 2, 3, 4 carbons off of it and a double bond that's conjugated with the ring system. All right, so here is my ring, and there's 1, 2, 3, 4, and there's the double bond. So this is what we need. We need to make this using the Heck. All right, so I know that I'm going to have a bromo group on something, and the Heck also requires some type of carbon-carbon, preferably terminal alkyne. And I need something else probably along with it to make what they give me up here, but these are just kind of my starting places. I need palladium, and typically the CH3CH2 triethylamine. Okay, well, there's the ingredient list. I kind of know the puzzle pieces. Now I just need to put it together. All right, so how do we do this? Well, I'll look up here. Look, there's my double bond. So I could right there, and that breaks that bond to that particular group. So it looks like if I take my ring system and have a bond that points to a halogen there, and in this case a bromo group, there's my aryl halide that this reaction's going to want. And then over on this side, what I have out, okay, well, there's my carbon, double bond carbon, and then I have a carbon that goes off of that, and then a carbon that goes off of that piece. Folks, that's all that I need to do. So there is one example of how to use the Heck in order to make that product. Now, it also told me Suzuki. Okay, so I need to go through and make the same type of product now with the Suzuki reaction. All right, so here's the Heck version, and now I have the Suzuki version. Well, how do I get the Suzuki version? Well, think about how that reaction happened. Think about what made it different. It first wanted a boron-containing group, right? And off of this boron, we had 3 bonds, typically to some types of oxygens. And I'm just going to put R groups here. They can be anything they want to be. They can be halogen or hydrogens. They can be carbon chains. It can be a ring, like the big globby ring that we used back when we did Suzuki. But at least that's a starting point for me. And we said that whatever is attached to that boron, that is what's going to get attached to the halogen-containing group of the Suzuki. So it looks like I need this piece attached to that same ring. Look at this. It's the same ring as what I did with the Heck version, right? There's my aryl halide. If I can take this bromo group off, and if I can replace it with a carbon double bond carbon, and then off of that 2 more carbons, 1, 2, folks, I have it. That's all that I need right there. So that is the major difference between Suzuki and Heck. Well, on the arrow, if you wanted to be particular, we did use palladium for that as well, and we typically used some type of base like OH. So a minor detail though, compared to the reagents that are required for both of these reactions to go forward. That's the only difference, and we end up getting the same product. So the thing here is, do you want to do the Heck, which requires an aryl halide and an alkene? Pretty simple to get, right? No big deal on either one of these. We keep these pretty much in stock in our lab all the time. And then over here to the right-hand side, this palladium is still a palladium catalyst. There is no difference there either. But the bases are typically what's also different in these two reactions. So here's triethylamine or just the simple hydroxide base that you would like to use in a lab environment. All right, so there's the Heck version to make that molecule, and there is the Suzuki version to make that molecule. All right, so that's pretty simple, I hope, right? I mean, kind of straightforward. Break it up into two pieces, glue them back together. There's the two pieces that you need. All right, now let's take a look at B. For B, it looks like it's a benzene ring, and then off of this is a 1, 2, 3, and 4, but they're all single bonds. So this is kind of strange because it's very similar to what they just gave me with a pretty big difference here, and that is this 4-membered ring, but there's no double bond. There's no double bond here. All right, well, let's start with Heck. So when we do these with Heck, we typically look at the structure, and this is what they want me to make, and I try to find that double bond. But there is no double bond. Oh, so I can't the bond anywhere. Okay. But that's okay because back in Chemistry 251, we talked about how to break a double bond. So if we could make something with a double bond, that would be fine. I would just need to destroy that double bond eventually and take it back down to an alkane. And that's exactly the road that Heck wants us to do. All right, so meaning that pretend like here is the piece that I need to add on right there in the brackets. So we're still going to have this ring structure, and we're still going to get a halogen off of that ring, and there's my aryl halide. So that is one requirement for the Heck or the Suzuki. Remember, Venlic halides or aryl halides. And there's the case right there. Okay, well, the other piece that I need to add on, 1, 2, 3, 4. All right, 1, 2, 3, 4. The problem, though, is that in the Heck, this is going to be difficult, and the reason is because there's no double bond. The Heck requires that double bond. All right, well, that's no big deal. I'll just put it there. There's my double bond. Now, I know that that's not the product that we're after, but it's pretty darn close, right? So if the Heck goes forward, that bromo group is going to leave, and then that carbon double bond carbon goes on in that spot, and then 1 and 2 more. So there's my 4 carbons, right? There's 1 carbon, 2 carbon, 3 carbon, 4 carbon. Well, this is not the product that's up here, but I can get to that product up there if I can break the double bond of the alkene. And I hope that you remember how to do that from Chem 251 because it's going to come back and haunt you. I told you that it would in 251 when you had it with me. And this can be something like H2 and platinum. All right, so this H2 and platinum, H2 and Linlar, whichever one you want to use, one's a little bit weaker than the other. It takes a double bond and it completely destroys it. So here's my 1, 2, 3, 4 carbons, ding, 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 and then that double bond breaks, and then 2 sites of attachment open up, a hydrogen goes on one, and a hydrogen goes on the other. That was H2. I mean, where else is the H2 going to go? It's got to go somewhere. So we break the double bond, and 2 sites of attachment open up. H goes on one side, H goes on the other. There you go. There's our organic product, and that's exactly what we need from the question. So a lot of times we don't draw the hydrogens. Again, we kind of make the assumption that you know that they're there when we don't draw them. So there we go. That is the mechanism of how we would go through with this with the Heck reaction. So the addition of the alkene and then the palladium catalyst comes in, helps join those 2 carbons together in matchmaker heaven, and then we add hydrogen and platinum to that to destroy the double bond, and we get basically the product that they're after. Now let's take a look at this with Suzuki. All right, so with the Suzuki reaction, we typically have to have an aryl group or a Venlic group, just like with the Heck. So this would be a very good place for me to start as well. We also know that we have to add on, 4 different carbons at least. Well, this is no big deal. Here's my boron group, right? And I would still have these oxygens out here. I'm just going to put random R groups there. It doesn't really matter what they are. I don't care. I hope you don't care. It doesn't bother me, and it shouldn't bother you. But on this boron, we're going to have to add a group on. And this group is going to be 1, 2, 3, and 4. And remember, these groups that get added on to this reaction, they can be double bonds, they can be rings, and they can be single bonds. Remember, we had 3 choices of that, and alkyl groups were one of those accepted groups. So by doing this, this saves us an extra step. We can just take the Suzuki, we can take that borane compound that has the butyl group, and then we can react that with that bromobenzene structure that we have over the left-hand side, and that gives me the product that we need for this reaction to take place. Now, keep in mind, I keep writing PD, and I leave that off, but I want you to understand that there are 2 ligands that are there, and those 2 ligands can be interchanged with many different groups. It really doesn't matter what they are. There's so many different choices out there right now for them, but that's another thing that I can leave off to simplify these reactions for you. All right, so there you go. That's really all that we need. Now, the other question that you might see in a question like this would be, okay, this is great. You picked out the boron-containing group. Good for you. Now, how would you make that boron-containing group? Oh, do you remember how to do that? Well, if we come up here, and I'll take my boron, right, and I have this OR group. Okay, how can we make this piece that has 4 carbons on the outside? Well, the way that we said that we do this is we'll take the group that we need and we add a double bond right there. And what happens is that this double bond reacts with this boron that has a hydrogen on it, and we get a to the hydrogen and a to the double bond, and we have a connector now that connects the 2. So this is one of the ways that we can make the borane containing group, but the question didn't ask for this, and quite honestly, I don't really ask it that much either on a test, but some people do kind of inquire about where do you get that borane, because a lot of times we make this as the reaction goes forward. We make it directly in the vessel as we need it and as the reaction goes. All right, let's look at another example. Here we go. This is example. Heck can make the following compound in 2 ways, so how do you do it? That's a pretty nasty big molecule looking thing, right? I mean, it looks like it's looking at me. I mean, I see kind of this thing here, which is an eyeball, and an eyeball here. I mean, I don't really feel comfortable with this thing. Do you? No. I mean, this is a mad organic reaction right here. So it just bothers me when I look at it. I don't know. It's just me. All right. So let's kind of go back and let's get a erase. That makes me even more bothered. Let's get rid of all of that mess. All right. So here's my molecule. And this molecule, I need to make it in 2 ways, according to the Heck, blah, 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 blah. All right, so I know that this reaction, no matter what I do to it, it's going to have this palladium, and it's going to typically have this triethylamine that comes along with it. That's what they write down the most, so I'm just going to stick with that to make it match. So I know that's a requirement. I also know that some kind of aryl group is also a requirement as well. So I need to maybe look for a bromo group directly attached to a ring. Or the other possibility here is a Vinlic. So if I can get a bromo group that's also attached to a Vinlic, that also will work. Okay, so let's just take a look at my choices. I'm going to look at this molecule and I automatically zoom in right here on this double bond, right? So I'm going to go right there. There's my 2 pieces. All right, so what this allows me to do is it allows me to take this benzene ring, there we are, and this has a carbon to another carbon and a double bond O. So a carbonyl is right there. And it looks like the bond was right there, and I'll just crank it in 2 pieces. So my halogen maybe could have went there. Right? I mean, that halogen is on a ring. It's on an aryl group. Not a problem. I just keep going with it. Well, what that leaves me now is this double bond, which is what the Heck requires. And that is going to eventually go to a ring structure. And there's the ring structure with an OCH3 group on it. Okay, well, there's one way that we can do this reaction. I mean, that's perfectly fine. And by those bonds in half, I get two pieces of the puzzle, and each one of the satisfies the requirements of the Heck reaction. I have my aryl halide that's over here, and now I have this double bond molecule that's over here, and that's all that we need, and the Heck can go forward. All right, so there's group number 1. Now, the problem, it says it can be made 2 ways. So how do you do this? Well, that basically means that we have a choice. All right, so I'm going to erase our choice number 1. We now know that that's one possibility, and I need to go back up here to the starting mark, and I need to crank that side. It's as simple as that. All right, because look at this. This side, if it cleaves over here to the right-hand side, that allows me to take this benzene ring with a OCH3 group off of it, and here's a bond, and that bond right now is going to go to a halogen. So there is my aryl group, and that is a different choice because the other choice had my bromo group over here on this side, and that went to a ring with this C double bond O group on it. Now I have a halogen that's on a ring with an OCH3 group. So by definition, this is a different choice so far as long as the other half works out. Well, what do I have left over? Good news, it's a double bond, and that is what the Heck requires. So there's the double bond, and that's going to go to the ring system. That ring system is right there. And then off of that is my carbon with my double bond O. So again, a different type of alkene that is different than choice number 1. So by far, this is a completely different setup, and it was basically due to how we cleaved on either side of those double bond areas or those sp2 carbons. All right, so there's choice number 1, and there's choice number 2. So there we go, folks. That's all there is to it. All right, so pretty simple, I think. Pretty simple. It looks complicated. I know that it feels somewhat overwhelming in the beginning, but as you do these over and over and over, like we have a hope that you become more and more comfortable with these reactions, and that's what it's all about, right? I mean, I'm not asking you to be the master of organic. It might seem like it sometimes, but I'm not. All right, so in the next video, we're going to take a stab at the last lecture topic. Yes, I said that right. The last lecture topic of organometallics, and this is a metathesis, not a metathesis. Do not call this metathesis. It's not a metathesis. I had an instructor one year that looked at me in general chemistry and said that this was called a hypothesis. And it is not a hypothesis, it's a hypothesis. And this is a metathesis, not a metathesis. But that's just the way it is sometimes. All right, so here we go. We're going to start on a new section, and this new section is called metathesis. So in the next lecture video, we'll talk about what metathesis is, and we'll go through and we'll figure out how these reactions go forward and what this fancy little thing is all about. And you're going to see that this is no more complicated than any of the other organometallic reactions that are out there. So just sit back, enjoy the show, and I'll see you in the next video.